Hello, John here again, and this is episode 13 of the Lunar Lander machine code conversion. And in this episode, if you remember in the last one, our scenery was bigger than our lander could navigate horizontally, because we're only looking at the low bind, and we didn't even set the high bit. So what we're going to try and do, well, what I was going to do originally, it was after the video, I was going to look at changing the scenery and modify it to accommodate the weakness that I've put into the program. But instead I thought, no, I want to use the whole screen. So what we're going to have to do is we're going to have to alter the game to allow us to be able to set the high bit so we can use the full size of the screen. So with that, the problem we've got, and let me try and explain. So I'm gonna, if I can find the snipping tool. There we go. There we go. I'll just put that to one side. So if I run this, need to be on the right one. If I F5 it, just wait for it to compile and start up. Here we go. Right, I'm going to pause it. There we go. Now, if you remember, the lunar lander would only go to about here, I think it is. Hang on, let me restart it. I think I don't think I've got debug on. Hang on. I think I'm going to run out. Hang on. Let's turn debug on, because I think I turned it off. Memory. Can't remember now. I think that's it. It's been a few weeks since I've looked at this. Unfortunately, work's got in the way. Right, start again. Hopefully I'll put it in demo mode now, so we can put the lander in the place that I was thinking of. There we go. Right, we go to 41, 50, right there. So if I go down, you'll see that the lander is just off the platform. There we go. If I go one more over, so 255, one more, bang, it's gone. Bring it back. Right, let me just pause this because that flashing is really annoying. Right, what I want to do, so if I use the snipping tool and just grab the screen, there we go. What I was thinking was, I don't want to lose the full screen, because when we do the other sceneries I want to be able to have the full screen. The problem is that if we come over here, when we extend the range and sort the shortcomings of the maths to get over here, we're going to get in the way of this here, this region here. Like so, that region. Because what will happen is, if we do the full range, yeah, the lander come in here, it will collision detect and crash. And what we don't want is that to happen. What we want is the lunar lander to basically, if it comes to here, we either stop it, you know, so we stop it dead, or we say out of range. I think the lunar lander does that. I think the Jupiter lander does that. So what we need to do is we need to test for this area here. Yeah. So when you do hit here, we say that if it's here, the question is, do we say they've crashed? And I think the only way we can truly find out is by loading the lunar lander in, you know, the Jupiter lander, and see what they do. Right, can't remember where I put it now. Can't remember where I put it. And this doesn't have a recent one, does it? Where did I put the lander? Let's try this one. Oops. Didn't want to do that. Just fired another one up and didn't want to do it. Where is the emulator? There it is. So put that there. CRT. There we go, Jupiter lander. Right, so let's see what this does. So A and D, F1 fire. Okay. Now this won't go off the sides because, let's just pause it for a sec, because they've gone all the way up on this side, look. So they won't hit the bar, but we can always test this bit, see if we can get through this bit. But it looks like it could be on. It looks like it goes to the top, but they have a test that goes off the screen. So let's fire it back up. Oh, too fast. God dear. Yeah. So it goes out of sky. So they don't crash, it just restarts again. Right. out of sky. So we could do the same sort of thing, I suppose. Instead of out of sky, say out of range or something. Okay. But you can see the dilemma, because we've got this here now, which is going to be our fuel and our velocity indicators. We don't want it to collide, or we allow the lunar lander to go behind it or in front of it. It will detect, but then because we say from this line onwards and above, say this line, because I'm going to put some text there, that it's fine. Anything in this yellow area we would class as not problematic. Yeah. So we'd have to put this testing on the collision to see if we've passed this X point here, and if we have, are we less than this Y point? And if we are, then we don't, the collision flag, we don't set it, so it doesn't think it's collided, even though we have collided, because this is going to stay there all the time. But we could all, I mean, on the lunar lander, they've got the landscape going all the way up there, but that's still out of the reach of the lander, which is only sort of that high. So this space is just wasted, and this space here is just wasted. So we're going to change the maths in the program to allow us to go and use this space effectively. So let's see where we're going wrong. Right, so we're going to the lander, and this is what we're doing, yeah? So we're doing the calculation, that's the demo mode. So we're doing the demo mode is there. So this is the proper one, and what we're doing, we're doing a 16-bit add and subtract on the horizontal, which is the 16-bit is including the fraction, and so the horizontal fraction, inertia fraction to horizontal velocity fraction. So yeah, so it's only doing 16. It's only doing the 16-bit. In fact, that's not the right place, is it? Because that's gravity. That's updating the inertia value. So where's my updating the X and Y? Read inputs, update sprite position. I bet it's in there. Here we go. Yeah, it's here, look. So this is where we're adding the velocities to the lander X and Y, but it's only 16-bit, so it's going to be the fraction and then the low byte, and not even touch the high byte. So what we need to do is we need to be able to add and subtract not 16 bits but 24 bits, because then that will be the high byte of X and the low byte of X and the fraction for X. So we need to write another routine. Now, have we got that in here already? So in the maths part, so we got 8-bit, 8-bit, 16-bit, 16-bit, and more than likely it's all the new ones that we wrote at the bottom. So these, yeah. So we're going to need to write another 2 routines to do 64-bit maths. Yes. Right, so let's get that done. So we'll just copy this. Put that in. There's the 2. So we'll call this 24. And it's the same thing, it's an address, an address, an address. But instead of being words, they are... What's a 3-byte translation? We'll just put 3-byte. Bytes. Okay, so we're loading in 1, we're storing in 2, adding 2, storing in 3. So we do the same here. Where we are loading 2, 2, 2. So if the carry set, then we load that, add it with carry, store it. If the carry set, it transfers onto the 3rd byte. So get most significant byte of the first number. Well, this is... Yeah, I suppose we can use the same words. It's effectively the same. So we'll do this for here. So instead of add, it's SBC. Subtract. Ooh. Yeah. So 3 bytes. So when we look at the memory, we should have 3 bytes. X, 1, 2, 3. Yeah, that's right. And the velocity is only 2. Inertia is the velocity, isn't it? That's only 2. So what we need to do is we need to put another one in there. Pi. That should do it. Don't need to do inertia because that's just affecting the velocity. But we need to add the velocity to the x, and the x is now 3 bytes, so this is going to match it. But that'll never change from 0. Right, so we need to go back to where we do our maths, which is here, and we're just going to do exactly the same, but we're only doing it on here. 24. So the x fraction with the velocity fraction. Yeah, that's what we're looking at. Yeah, the velocity fraction. Put it back in the x fraction. And then we need to the velocity fraction is fine, still 16-bit. Right, so the positioning of the sprite shouldn't have changed. Sprite position, X high. Right, that should allow us to get all the way to the edge of the screen. Okay. I want to. There we go. I want to get rid of that. Oops, wrong one. Just want to rem that out. And here, we'll rem that out as well. Stop the flashing. Right, let's run it. Let's run it. So we're still in demo mode, so hopefully we should be able to go all the way across the full length. Right, let's see. See if we can go all the way along. Well, we haven't hurt it because it's moving. So our 24-bit calculator must be working quite happily. So I'm going to just stop just short. Here we go. I'm going to go down. And we'll go below the bars. There we go. Right, let's see. Oh, it didn't work. Right. So, why didn't that work? Why didn't that work? So add 20, so it's the X fraction with the velocity goes back into the Lunar Lander X fraction. Add 24. So add 24. That should be right. That should be right. Lunar Lander X. Horizontal velocity, which will be 1 in this case. Lander. Let's just have a look in demo mode. What am I doing in demo mode? Oh, I see. So this is where, right, so it should work in normal mode, but this is where it's going wrong in demo mode because we're using the 8-bit add. So we need 16-bit. That means that the demo increment memory place needs a high byte here. Needs a high byte, which is going to be 0. Right, so that's demo mode. Let's try it out just to make sure. F5. And then we'll take it out of demo mode and see if I can make the lander go across and see if it uses the full width of the screen. Cool, computer's on a go slow today, but it's Windows updates coming in. Right then, go across. Now the number across the top will blow a fuse because I think we're setting the high by to nothing when we print it out. So we'll get just before, there we go down. There we go. And then we'll go across, and there we go. Cool. Right, okay, so let's get out of demo mode and put it back into normal mode. I better add a comment here because I keep forgetting. Note game mode 255 demo mode. Right, so that's put it back into game mode. Right, let's see if the game controls work and whether we can get to that bit of the screen that we couldn't get to before. Here we go. Right, down you go. Gonna run out of fuel before we get there. No, I think we're gonna be alright. Here we go. Do we go over the point? Yes, we do. Excellent. Bang. See what I mean by if we collide with the bars, we'll end up crashing. Right. That's great news. Great. Oh, up we go, up we go, up we go, up we go. Boom. Well, I think the fuel's been reset. Yeah, it is. Right then, so. Okay, where's the lander now? What was I going to say? Oh, missed the top. Oh, I've run out of fuel now. Run out of fuel. Boom. Right then. Cool, it's 29 minutes. Right, okay, we'll call this video a day. So, what we've done is now we've got the lunar lander to be able to use the full size of the screen. So in the next video we're going to have to test for the collision with the bars, and if it's collided with the bars, not to mark the die, not to go through the die routine, and allow it to just go over it, or just allow it to go over it. And then, so that can be the next video where we put that in and test it out, and if we've got time we'll work out the true landing points for those 3 pads, and probably that'll be the next video after that, because I'm trying to make these small videos and failing miserably, because this is now into 30 minutes. Oh well. Anyway, if you like this video, please hit that like button. If you don't, fine, hit the dislike button. Always leave me a comment. I will answer as many as I can get. And if you like this channel and you like what I do, consider supporting me on Patreon, because all the money that's generated for the channel comes back into this channel. And with that, I'll say ta-ta for this episode, and I'll see you in the next one. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.